Alright, so let's take a look at a second type of mining, a second type of surface mining. Strip mining is a general term for any type of practice of mining where a seam of mineral has been located, but it is under layers of soil and rock, which we're going to call overburden. So in this picture here, you see the overburden is up here, and that overburden needs to be systematically removed. What we're going to do is we're going to expose the layers of mineral, or what we call a seam. All right, and then we're going to systematically remove that seam in a series of strips to extract and process the mineral. Okay, to give you a sense of how this is done, I'm going to draw a nice little diagram here for you. Okay, so here we have our environment, and there just so happens that there's a coal seam underground that has been located by a mining company, and they're going to want to go ahead and expose that coal seam and extract it for processing. Okay, so the first thing we need to do, the first step of this process, is to remove the trees. So that deforestation is done by cutting, and then the lumber is usually either sold or burned. Okay, so removal of the trees needs to occur, and then we have to remove the overburden. Alright, and we remove the overburden either by drilling or blasting. And that overburden is going to become a problem because we need to store that somewhere. When we're finished with this mine, we're going to want to put things back, hopefully as close to the way it was as possible. We call that reclamation. So for the reclamation process, we need to store this overburden so that we can fill our mine back in later. The storing of the overburden usually occurs either off-site. Alright, so we're going to either put this stuff off-site, or we're literally going to take the overburden and put it right behind us, and that ends up to be done in a series of steps, which will create literally a man-made mountain behind you. So then later you can take that mountain and just refill your hole. Now we've exposed the coal seam, the mineral itself, so we're literally going to excavate that mineral and load it onto trucks, sometimes trains, to transport for processing. Okay, so it's as easy as that, but you can already think of some of the environmental impacts of this. Okay, the deforestation, the problem of the overburden, where you're going to expose soil and rock and put it into a pile, and what they're going to do is they're going to step this on slight angles to basically stabilize it so it doesn't collapse. Alright, so you'll see that when you see pictures of strip mining. They actually have a name for that. The steps, the flat part, are called benches, and the angled part are called batter. Alright, and then we call the series of them steps. Alright, so the benches, the batter, make up the steps, and then that procedure helps contain rock falls. Okay, sometimes you need additional ground support, things like rock bolts, cable bolts. If I go back a slide here, you can see the series of steps, benches, and the batter. And there's roads built within those to take the ore from the bottom of the mine where it's being excavated and take it away. So we'll excavate these seams until either the mineral is exhausted or the ratio of overburden to ore makes further mining uneconomic. Okay, here's just another picture of what we drew. And you can pause this and read this through if you'd like. Alright, we get a lot of our non-renewable minerals through strip mining. Alright, aluminum is a nice example. And I mean non-renewable, and some of you might be thinking, well, you can recycle it. And that's true. It's renewable in that way. When I say non-renewable, I'm talking about there's only so much aluminum on the planet. And when we exhaust that amount, that's it. It's non-renewable. We can keep aluminum in the materials economy through recycling, and that's what makes recycling so important. So if we're thinking in a sustainable way, if we want our future generations to have the same conveniences and things that we have today, we need to make sure that they have aluminum in the future. So we need to make sure we mine less, which means recycling more. Okay, so that's the importance of recycling and what it means to be non-renewable. The only things that are renewable are things like sunlight, water, wind, things that are always going to be there. They're constant. And we'll talk about renewable energy sources, but I need you to know the difference of non-renewable and renewable. So aluminum is a non-renewable mineral resource, which is extremely common on the surface of the earth. It has a tremendous weight to strength ratio, and that's what makes it so nice and useful. All right, it's durable. It has ancient uses going all the way back to the ancient Egyptians. And the most important thing in my mind is that it is recyclable. All right, we can keep this in the materials economy, which makes it really nice and cost effective for companies. And just so you know, aluminum comes from the ore bauxite, and then they need to take the aluminum out of that ore. And that's what the processing is all about. But when you process that, we want to get out the pure aluminum, and they make things called ingots. All right, ingot is a general term for a metal that has been put in some form. In the case of aluminum, the ingots are these like sectioned pieces of raw aluminum. So these will then go off to be processed and into the products that we need and use, like aluminum cans. Here are a bunch of the more important mineral resources we have. And you can see in 2004 the production of these things in thousands of metric tons. All right, so let's compare here. Here you go for aluminum. Copper is another important mineral resource. Phosphate rock is mined for fertilizer. All right, obviously iron, and then you got zinc. But take a look at these numbers. When you look at the amount of copper being mined in 2004 alone and compare that to the amount of zinc, we're using and consuming zinc at a high rate. And then you go down to the bottom chart here and you ask yourself how much zinc is left, and you get a little nervous when you see that it's been estimated of 22 years of supply of zinc. So in our lifetime there might be a crisis with the amount of zinc in the world. And you look at this too, this one is somewhat concerning too, because you think about the amount of copper that we use in our wiring and electronics. All right, so we're going to need to find substitutes or really step up our recycling of these types of products. Okay, aluminum, like I said, is very common, and then you take a look at iron and nickel as well. So here's a picture of a strip mine. All right, they load the overburden or the mineral onto these conveyor belts, and things are separated, and what needs to be disposed of goes on piles, and what needs to go to processing goes somewhere else. All right, to truck or train. Moving along here, a third type of surface mine is called an open pit mine, and you'll see pictures of these things. They're absolutely gigantic. It is a form of strip mining because you see the benches and the batter, which make up the steps that go all the way down deep into the earth, which has exposed mineral ore, which is extracted and then off to processing. So these open pit mines are basically techniques to mine mineral deposits that are close to the surface, but they resemble pits rather than stripped earth. All right, so think about the amount of overburden. Think about the amount of waste rock, okay, which is all piled up either nearby or off-site. All right, there's a lot of piles of material. Here's what's called a tailings pile. Tailings is a general term for ore that's been processed and piled up nearby, and that becomes an environmental problem as well. But let me introduce the word tailings pile here. All right, but these open mines are huge. You can see the scale here, but by the size of those trucks, which are the largest trucks in the world, and they are dwarfed at this scale. Okay, here's another one. This is a bauxite mine. You can see the copper color in the rock on the side of the face of the open pit mine. Just huge, huge operations. Down here in the lower right, you see some of the tailings piles. All right, some of the piles of stuff left over from the processing of ore. Okay, but you wonder, where has all that overburden gone? All right, these copper mines are extremely important because we use copper everywhere in our lives. Extracted from the ore chalcopyrite. And some of you might see or know pyrite as being fool's gold, so that's that's a metal. In this case, chalcopyrite is the ore of copper, but copper is very ductile. You can mold it. It's extremely useful because it has high conductivity, which makes it useful in electronics. Okay, it's actually essential to all living organisms. So it's put in things like vitamins. All right, it's a trace dietary mineral. All right, it's actually used in the respiration process of our muscles and bones. It's also found in our liver. Again, we use it in electronics, wiring, architecture. There's other antimicrobial applications. So copper is extremely useful in today's society, which makes it in demand. Alright, so where do we find copper? Where's the mining going on? Large amounts of copper are coming out of the country Chile, okay, in Peru, China, and the United States, among other countries. But Chile by far leads the world in the recovery and production of copper. Okay, a nice case study here is called the Pascua Lama project in Chile. This open pit mine operation is not currently in production. It is kind of on hold. It's on the back burner. This project is being planned to mine gold, silver, and copper in Chile at the border of Argentina and Chile. If you notice here, the project is pretty expansive and controversial project because of its close proximity to glaciers. If you look at this map here, there's at least 4 glaciers that are pretty close proximity that would be impacted by this project. So the controversy behind this project is all about glaciers, but it also has the potential to impact the water supply for up to 70,000 farmers that are in and around the area that rely on both the glaciers and groundwater for agricultural purposes. This mine also has the potential to release things like cyanide, mercury, sulfuric acid into rivers. But projects like this provide jobs, and that goes a long way, especially in developing countries. So the project has not been approved by the government of Chile. There's a lot of controversy behind this project. There's also a lot of struggle. To find the funding to pursue this project. All right, so it's on the back burner as of right now. Argentina is in full support of this project, but Chile is a little bit more hesitant due to the environmental impact. They've gone so far as to say that the glaciers they will impact, they can actually relocate them, and if they're going to impact the glacier, they'll take what they're going to impact and move it and add it to another glacier. And you can be the judge of whether you think that would be a good idea or not. But that was one of the solutions to the problem, to actually move a glacier. But what the Pascua Lama project gives us is a case study in some of the challenges and impacts that mines might have in other places of the world. And it also shows us that these things are usually placed in environmentally sensitive areas, in this case, near glaciers. Okay, so that's another case study for you. Here's another open pit mine. You might see a little bit difference in this one from the other ones that we've been looking at. You might see straight walls. Open pit mines for building materials or stone are called quarries. And I happen to grow up around quarries my entire life. Alright, this is the town of Nazareth, Pennsylvania. And just next to Nazareth is a town called Northampton. And if you went to Nazareth, you were a Blue Eagle. If you went to Northampton, you were a concrete kid. Because in this area of the world, their underground is called the limestone belt, and an open pit mine that mines building materials like limestone, all right, is called a quarry. So this is a limestone quarry. And I used to own a house basically right here. All right, so if you walked out my backyard, you would fall into a limestone quarry. So you see a quarry here, you see a large quarry operation here that's filled with water, so that's obviously expired. This area of this quarry is filled with water, so that's obviously expired. But you see these large, giant operations still continuing in my hometown. And what they do is they pump the water out so that excavation can continue. And this is on the one side of the town. There's an identical series of quarries on the other side of town, and that's just in Nazareth. Northampton has a whole bunch as well. So limestone is mined and crushed and produced into cement. So a lot of the world's cement for building comes from the Nazareth Northampton area in the limestone belt of eastern Pennsylvania. And here's a Google image of the area, and our limestone belt is about right here, underground. Limestone is literally calcium carbonate, CaCO3, which is a layer of dead ocean critters that's been piled up and turned to stone. So this part of the world was a shallow ocean environment for millions and millions of years, which is why we have underground limestone today. And just so your bearings are correct, Souderton is down in this district right here in Montgomery County. But interestingly enough, just north of Nazareth is another underground belt. And this one's a little different. Not limestone, but slate. And the area of Penargil and Bangor, Pennsylvania is right dead center in the middle of the slate belt. So a lot of the country's cement comes from the limestone belt, and a lot of the country's slate comes from the slate belt. And we use slate for many different things. It's a building material. We used to use it for roofing shingles, things like that. Okay, so very interesting local history there. All right, here's a slate overburden or tailings pile right next to a baseball field in Penargil, Pennsylvania. And those pieces of slate that are on that pile are gigantic. You would not be able to lift one of those up. It's bigger than a table, right? And that's a huge, huge pile, one of many. Here's another picture of a quarry that's been decommissioned and is now filled with water. Okay, the fourth type of surface mine is called mountaintop removal. Pretty self-explanatory. Mountaintop removal is just that. Remove a mountaintop to expose a seam or a mineral deposit for extraction and processing for the mineral itself. All right, this one is also very controversial because it is the most environmentally destructive process of the mining industry. To literally take a mountain away has tremendous environmental impacts. However, the coal business says that this method is safer and cheaper than subsurface mining, digging tunnels and shafts, and it's more economically feasible. Alright, our case study to talk about mountaintop removal is Appalachia in the states of mostly West Virginia, Kentucky, and Tennessee. In this area of the world, there's over 500 total mountaintop removal projects, and it's nearly 1.2 million acres, an area almost as large as Delaware, have been heavily mined in this way. So let's talk about this a little bit and the process involved. Okay, again, the first step here is to remove the trees on this mountain. So you're immediately going to impact biodiversity and land ecosystems. All right, and when you remove those trees and that land, you have to put it somewhere. So one of the more controversial things to do with it is to literally fill a valley. All right, so nearby a mountain, you're going to have a stream which downcut a valley, and what we're going to do is we're going to take the top of the mountain off to expose, in this case, coal, and we're going to fill this nearby valley with the material. And we call that a valley fill. All right, and that's controversial because a stream is going through here with aquatic ecosystems and a lot of biodiversity relying on that stream, and we're literally going to fill it in. And we're going to kill everything that relies on that water source. Alright, so if you look down here on step number 2, we've now removed that mountain and created an area where we can access that coal seam. Okay, so mountaintop removal is literally a type of strip mining. So what we're going to do is begin the mining process and backfill, continuously taking the mineral and backfilling. So if you go down here to the next stage here, we're mining the mineral, which are these numbers, and we're extracting the ore and taking it off the processing, and any tailings or overburden we're just going to put right behind us, so that when we're finished, here you go, you just have a big pile of unwanted stuff in place of the mineral that you took. Okay, so hopefully that makes sense. Let's look at a couple of pictures here to give you some imagery. Alright, here you go. You can see how environmentally destructive this actually is. They're literally removing the mountain. And any ecosystem that was once there, or any species that relied on this, is now gone. Okay, but again, this is a tough one. Mountaintop removal in West Virginia, Kentucky, and Tennessee is done for coal, which provides about 50% of the electricity generated in the United States. All right, so coal is in great demand here in the United States. We're still relying on burning coal to generate our electricity. So what we can do as citizens, lessen our electricity use. All right, turning off your lights when you leave a room is literally helpful. All right, historically, underground coal mining was the leading method, but since the use of explosives and heavy machinery became more readily available, you can excavate 2.5 times more coal per hour with less manpower using methods like mountaintop removal and strip mining. All right, so the industry itself saw the number of jobs decline by 60% from 1979 to 2006. In a 7-year period in the 90s, we saw 10,000 jobs lost just in that 7-year period. Coal mining does have a deep history in the United States, and it has very close political ties. So there's a lot of supporters of this type of procedure, mountaintop removal and strip mining of coal, and it gets a lot of political backing, which helps the industry. All right, but it is very environmentally destructive. So even though there are protesters, a lot of times the environment suffers when it comes to especially mountaintop removal.